Before I get into the homework questions, this is how we're going to start every day. I'm going to name two angles. You tell me what's the name of them. Second person's going to tell me what you know about them. You got a 50-50 shot. They're either congruent or supplementary. Okay, we ready to go here? Because this is no joke. This has got to be, boom, lights out every time. All right, quick and correct. So I am going to start with 2 and 6. 2 and 6. What type of angles are they? 2 and 6. Here we go. 7, 2 and 6. Corresponding. Yes, indeed, they're corresponding. So what do I know about them? Let's go 2. What do I know about them? They're congruent. Perfect. Let's go 5 and 3 now. Angles 5 and 3. 1. Alternate interior. Perfect. What do I know about them? We're going quick. 8. Alternate interior. Congruent. All good so far. 4 and 5. 4 and 5 are what type of angles? 18. Same side interior. What do I know about same side interior? 21. Supplementary. 1 and 7. 1 and 7. 19. Alternate exterior. What do I know about them? 2. Congruent. Final pair I'm going to ask, 2 and 7. 2 and 7. 14. Great.
2 and 7 are
Same side exterior. What do I know about them? Oh, not you. You had your chance. 30. Supplementary. There we go. Everybody good until we get to the homework now. Okay. Let's roll. What do you got for me today? Homework. Check your answers on Aspen. Now you come with the questions. Hi, Violet. 39, everyone. We had a little auxiliary lines, correct? Okay, here we go with the auxiliary lines. First of all, let's discuss why I need an extra line in there. Why did this problem require an auxiliary line? Well, you had the original 2 parallel lines, and then once I drew this in, is that a transversal for the original 2? No, because it doesn't go through the second one. And the same thing applies to this one right here. That's not a transversal. It doesn't go through both of the lines. So I added in that third line right there. That is parallel to the original 2. Why does that one work? Now everyone see my highlighted yellow line? Now that's a transversal because it intersects both of them. Now, I'm hoping at this point in the year, you would be able to fill in the surrounding 3 angles for where 125 is. I hope. Or you don't need to know anything about parallel lines. All right? Fill in 125 for the vertical and what, 55 for the supplementary one? Yeah? Okay. So I'll just fill in 55 here. Okay. We're using these 2. Can I do this? Let's see. Yeah, I can. Good enough. Okay. Using those 2 parallel lines. What type of angles are these right here? We just talked about same side interior, supplementary or congruent? Supplementary. So if that's 55, the one right above it has to be 125. The one next to it's a linear pair, so that has to be. And I get it. You could have said, hey, those are corresponding. Hey, those are alternate interior. I get it. Okay? Regardless, you still got that angle to be 55. Let's go up top. 105. Do you want the supplementary or the vertical one for this one? I don't care. Vertical or supplementary one? Vertical, fine. That's 105 as well. They're congruent. Now, ready? Those 2 lines are parallel. What are these types of angles called right here? Same side interior. They're supplementary. So if that's 105, this angle will be 75, and now take a look. Everyone see the two angles that make up angle X? 75 and 55. And that's where I got the 130 degrees from. Okay? So you guys got to take two at a time. Two at a time and work with them. Okay? Let's go. Let's keep this train going. Good, Vi. We all right here?
Yeah.
Great. Others, let's go. Let's keep it going. Because usually what happens if people don't ask, I pick certain ones and say, oh, you didn't have a question, so how'd you do it? Hi, Maya. Hi, Maya.
That was mine.
45. All right. How was your factoring game, huh? All right. All right. Great discussion. I just asked, but do I care? No. All right. Moving on. Here we go. First of all, could you have gotten away without factoring? I guess. You could have said y squared plus x is equal to what? $1.80. And then you could have also said x plus 8y minus 15 is equal to what? Yeah, good. You deal with that. Good luck with that. All right, I'm not touching that. All right, not touching that. I'd prefer to touch y squared and 8y minus 15 because what type of angles were they? Altered interior. What do we know about them? So that's the equation I'd like to solve. It all has y's in it. And I gave you a hint that, yeah, you're going to factor this, but not right now. You had to dig deep in your algebra days. You can only factor when one side of the equation is 0, so you had to move some stuff over. I always like whatever squared to be positive, so I'm going to keep the y squared there. Help me move over the 8y. Subtract it over. How about the negative 15? Add it over. All right, now I got something I can factor. You got to play the game now. Two numbers that multiply to 15, but will at the same time add to -8. Now look, I tell you numbers that multiply to 15, I'm sure the first things coming to your mind is what? 5 and 3. If 15 and 1 come to your mind, good for you, but 3 and 5. And now what's the only way I'm going to get them to add to -8? If they are both negative. All right, still equal to 0. So now you go to solve for y. On this side, y equals what? 3. And on this side, y equals? So you have two possibilities. Y could be 3 or y could be 5. Your x will change depending on which one you're working with. So let's take 3 right now. Y equals 3. If y equals 3, how many degrees do I have in this angle here? 3 squared, which is 9 degrees. And what's the relationship between 9 degrees and x degrees here? Supplementary, because they're same side interior, so 180 minus 9. If y is 3, that must mean x is 171. All right, well, there's another option. What if y was 5 now? If y is 5, that angle now will become 25, 5 squared, and you said they're supplementary, so 180 minus 25. X would also equal 100 and... Oh boy. It's 25 degrees. 180 minus 25. 155. Whew. So we have two possibilities, 5 and 155, or it could be 3 and 171 and still be true. Okay, that's part of having that honors attached to your schedule there. Next up, other ones we wanted to go over. Or I'm going to pick one here, and you're going to explain to me how you did it. Because I have another one I want to see how you did. Yep. Okay, that was kind of awkward. Okay, 28. I'll make this easy so I don't have to copy and paste it. The 5y and the 20. Same side interior. What do I know about them? So 5y plus 120 equals 180. Do we all have the ability to find the angle next to 108? I hope so. And then 2x and that angle are our same side interior, so they're also supplementary. Okay? So 5y and 120 are supplementary. 2x and 72 would be supplementary. Others? Nothing else? Yep. That's fine too. Another way around it, because they are what type of angles? Alternate interior. I love it. That's hopefully that's the one great thing about this, where we are this year at this moment, is multiple ways of doing it. Nothing else? We're all good? How do we feel about these angles? Because now you apply it to your statements and reasons. I know you miss them so much. Yes. Going back to proofs today, but before we do, I need to see what work you put into your homework. Let's see. Back to business. Here we go. If you find it helpful, you may want the last sheet of your test where I told you to keep. That's got all the theorems and facts. If you find it helpful. All right, if you want to try to do it without it, that's fine, because as you can tell, I've taken off the facts off the board. Yes, that brings me to the point. Next quiz will be Wednesday. Okay, next quiz will be Wednesday. All right, let's do this. I think some of you, this is going to be a wake-up call today for some of you. All right, how quickly these proofs are progressing now. Because not only are we going to use, oh, that's an alternate interior, so it must be congruent, but also it may have addition, subtraction, may have substitution, may have halves of equal quantities. All right, all in the same proof now. Because we are building now that we're in Unit 3. All right, I didn't want to throw you right into the fire, so what I did was a proof where I gave you all the statements, and you guys can help me fill in why they're true. Don't give up on the habits you've built in Unit 2. Whatever you have given, mark it on your diagram. So we have A parallel to B. How do we mark parallel lines again on diagrams? With the arrows, perfect. Doesn't matter which direction they're going, just as long as they're going in the same direction on the lines that are parallel. And also C and D. If you want to put two sets of arrows, that's up to you. Okay, here we go. Everyone see the proof statement, 1 congruent to 3. First, I just want to eliminate why this is not a two-step proof. 1 and 3, I don't recognize those as alternate interior, corresponding, same side anything. All right, so they're not any special type of angle formed by parallel lines. Everyone, can we agree on that? Okay, 1 and 3 aren't any special types of angles. All right, so let's get them congruent. So my first statement, I'm claiming that 3 and 2 are supplementary, and I want to know why. Look at where they are. 3 and 2. I first need to know what type of angles they are. 3 and 2. 2, what type of angles are 3 and 2? Same side interior, and we know what? They are supplementary. So that's why I wrote they're supplementary, but what would I write in my reasons? Same thing we wrote for justifications on Tuesday. What did we start it out by saying? What was given to you? Parallel lines imply Natalie, again, what type of angles are they? Same side interior angles are, what are we claiming there are here? Supplementary, perfect. All good. All right, step 3, I'm saying, oh, 3 and 2 are supplementary, so are 1 and 2. So are 1 and 2. Why? What type of angles are 1 and 2? They are not linear pairs. 1 and 2. 12, what type of angles are 1 and 2? Also same side interior, so it's the same reason. Parallel lines imply same side interior angles, supplementary. Now, if you were doing this proof on your own without me writing it in, you could combine statements 2 and 3 in the same one because they have the same reason. That would be fine. Oh, and then we get to the clincher now. Then why are 1 and 3 congruent? Now, oh boy, I knew that word was going to come out. It is not substitution. Remember, I did a big spiel up on the board last week. Substitution is only reserved for equal quantities, not supplementary quantities. You and your group right now, discuss, because it's something we've talked about. Okay, what did you and your group decide? If 3 supplementary to 2 and 1 supplementary to 2, why are 1 and 3 congruent from last unit? 12 again, why are they congruent? Because both 3 and 1 are supplementary to the same angle, angle 2. So supplements of the same angle are congruent. Welcome to where we are now with the proofs. And you're probably, that's not bad. Yeah, it wasn't bad because I gave you the statements. Okay, let's start clean right now. Okay, a fresh one where I give you no statements now. And that's not, I know you don't have that one. I got rid of that one. Here you go. There we go. There's the one. Go ahead, set up your statement's reasons, mark your diagram, and then we'll be in for it. Let's just fill it in, fill it in. We'll talk. All right, guys, here we go. First, I want to talk why this is not a two-step proof. I don't know if anybody's gears are turning. Don't mark it on your diagram. I'm going to mark it on mine, though, so you can see it. Look at my angles that I'm trying to prove congruent. CDF, we all see that angle. CDF. This one right here. And angle DFE. We're trying to prove those congruent. So some of you could have the argument right now, oh, this is going to be an easy proof because those are alternate interior angles, which they are. They're alternate interior angles, but anybody want to tell me why they're not congruent? They're alternate interior. They're alternate interior, but they're not congruent. Because what lines would need to be parallel for them to be congruent? Look how they're formed. Look, here it is. What lines would need to be parallel? CDN, FE, and I don't have that. Okay, so I'm just showing you that, yes, they are alternate interior, but they're not congruent because I don't know the proper lines are parallel. All right, so how are we going to get them congruent then? Let me mark the other congruent angles. CDA and BFE. Okay. Do you see, well, hey, they gave me lines are parallel. Does anybody see any special type of angles formed by those parallel lines? And I kind of just gave you a hint into the types we're talking about. There are alternate interior angles up there formed by these parallel lines. Where are they? Jacob? Take a look. Take a look. ADF and DFB are alternate interior. Now, I get it. You guys, some of you don't see that because it's not our traditional 1, 2, 3, 4, 5, 6, 7, 8 diagram. Ready? I'm going to give you a little very kindergartenish trick to notice alternate interior angles all the time. You see the letter. You see the letter Z. Good. We know our alphabet. Perfect. And the Z eats up the alternate interiors. Use it if you want. Okay? That's how you can identify alternate interior angles pretty quick. The Z eats them up. Okay? And that also works for the backward Z. Okay? Backward Z. All right? All right, so let's put those angles in our proof. Angle ADF congruent to angle DFB. All right, we wrote this in our justifications on Tuesday. What do you think is the reason here? What did you start out with? Parallel lines imply, still not right. Alternate interior angles are congruent. Okay, now we got to dig into Unit 2. What am I going to do with my given angles and the alternate interiors to get to the full ones? Oh, time out. How many pairs of quantities do I need to add? How many are written down? Okay, you tell me what you're adding then. All right, here, just one voice. 16, what are you adding together? CDA plus which angle? ADE. I don't think ADE is an angle.
Oh, crap.
Oh, boy.
Oh, ADF.
Rattled. CDA and
ADF.
ADF. There we go. Way to redeem yourself. That was embarrassing right there. Let's keep going now. You're not off the hook. Addition. And this is not changing even though we're in Unit 3 now. After an addition or subtraction, substitution. How we doing here? Are we okay? Oh, what was that? You're hungry for even a tougher one? You got it. Here we go.
said drink please. That's what he said. I said I will be typical. I have screenshots here. Yeah, it goes straight to Mel. I already
Hey, good stories. Here we go with this proof. Because this is going to be a challenge. I've heard some comments already. This isn't tough at all. It's going to be 2 steps. Because HGD and FEB are corresponding. We're done. Nope. Here's why. And I expect this, though. I expect you guys to say that day 2 of this unit. Let me show you why they're not corresponding. So you're talking about this angle and this angle. Yeah, they look corresponding, and look, they're on the parallel lines. But corresponding angles need to share the same transversal. Notice FE and HD are totally different line segments. Can't happen. Look back at what we did at the beginning. Ready? Where was it? There it was. 2 and 6 are corresponding, right? Right? Take a look. 2 and 6 are corresponding. That's because, yeah, they're on the parallel lines, but everyone see how 2 and 6 shares the same transversal. Okay, look at your proof you're doing now. They don't share the same transversal. So they're not corresponding, but I like the thought. Okay, I like the thought, though. All right. So how are we going to get here? Woo! Your given should have signaled something. It should have given you a hint into what is upcoming. How many angles are being bisected? Ding, 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 ding. What did that alert us to in Unit 2? Halves of equal quantities. All right, but it's still not a 2-step proof. There's a lot more that needs to go in there. Anybody remember when we did a halves of equal quantities proof last unit, what also needed to go in there? What are you taking half of? You needed to write that. So tell me the first angle you're going to take half of. Half of angle JEB is equal to, now calm it down, look at your diagram. If I take half of angle JEB, I have 2 options. I have JEF, or it could be equal to FEB, but we only care about one of those 2. Which one do we care about? FEB. Why that one and not the other one? That one is in the proof statement. So angle FEB. And you're taking half of what other angle? EGD. Look at your diagram. You could give me 2 angles that's equal to, but I'm only concerned about one based on the proof statement. So half of EGD is equal to HGD. Not by halves of equal quantities. What alerted in the givens that you're going to take half those angles? Definition of a bisector. This is why it gets tougher now as we move on. We are still not done. You're not ready for halves of equal quantities or equal yet. You may think you are because this is what we did in Unit 2 and we were done. But there's something in the givens that's not there that I gave you every time in Unit 2. Okay, here we go. It's 23 in the house. Oh, hi, Dylan. This should be good. Ready? Okay, I'm going to ask you a question, and I need everyone to listen up here. What's our last reason going to be in this? Yeah, very last one. We said this is a what type of proof? Okay, everyone say it louder for your classmates.
Halves of equal quantities are equal.
Okay, one more time and I'm going to cut you off at a certain point.
Halves of equal.
Stop. What you're taking half of has to be what? Look at what we've written up there. What did you guys just take half of? Angle JEB and angle EGD. Are those equal yet? No, in Unit 2, I'd usually just throw that in the givens. But they have to be equal before you use halves of equal quantities. What you take half of needs to be equal. Now look at your diagram. Can you tell me that JEB is equal to EGD? I hope so, because they are a special type of pair. They are corresponding. So that is going to be our statement 3. We are going to say what we're taking half of, angle JEB and angle EGD are congruent before I say halves of equal quantities. All right, what's a good reason here now? Oh, parallel lines imply corresponding angles are congruent. This is tough now. You got to remember a lot of stuff here. Now, also, could I have flip-flopped 2 and 3? Absolutely. You could have done this first and then the halves second. That's fine. All right, so finally, we're ready to say angle FEB is indeed congruent to angle HGD. Now we can say halves of 2 equal quantities here, of equal quantities are equal. You see what needed to go in the proof? What you're taking half of, and whatever you're taking half of, they better be equal. Questions at all? Plenty of time, 10 minutes to start the proofs. 10 minutes. Bounce ideas off each other. Hey, my versions are up on Aspen. Don't freak out if they don't match. All right, they still might be right. Just bring it in tomorrow. Okay, don't freak out if they don't match. Also, just don't copy them down either. Get nothing.